This video is on the energy levels of electrons. So this is the second part of chapter 2. We are going to talk about energy later on in the class, but for now let's just say that energy can be defined as the capacity to cause change, and a specific kind of energy is potential energy. So potential energy is the energy that matter has because of its location or structure. For example, if you held a ball above the ground, but you didn't release it, that ball would have potential energy because it's ready to fall to the floor, but it hasn't fallen to the floor yet. Or if you held a bow and arrow and you pulled back the string, but you didn't release it, you didn't shoot the arrow yet, but all of that energy was stored in the tension of the string, that string would have potential energy. It would be like ready to make the arrow go forward, but it hasn't started yet. Electrons also have potential energy, and the potential energy of an electron is related to how far away that electron is from the nucleus of an atom. So in this picture, we have an atom. You see the atomic nucleus, and around it are the electrons in the different shells. And here in this picture, we have 3 electron shells. Each of those yellow lines is an electron shell. Not all atoms are going to have 3 electron shells. It depends on how many electrons you have. But for this particular example that has 3 electron shells, I like to use the analogy of a 3-story building. So people on the bottom floor of a 3-story building have the least potential energy due to gravity because they're closest to the ground, right? People on the second floor have a little bit more potential energy due to gravity because they're a little farther from the ground. People on the 3rd floor of this 3-story building are going to have the most potential energy due to gravity because they're the farthest from the ground. But people aren't going to be found at floor like 1.5, right? You're either on floor 1, floor 2, or floor 3. Electrons work kind of similar to people in that analogy. So the electrons that are on the first shell, that's the closest to the nucleus, have the least potential energy because you could kind of say that like they want to be relatively close to the nucleus. Want is, anthropomorphizing them, but they have a tendency to be closer to the nucleus. Electrons in the second shell have a little more potential energy because they're a little farther away from the nucleus. And the third shell in this diagram has the most potential energy because those electrons are even farther from the nucleus. And so there's a little bit of a draw to fall back down. Electrons can absorb energy from outside of the atom. And when an electron absorbs energy, it can bounce up to a different electron energy level or a different shell. And after a little while, that electron will release that energy again, and it will bounce back down to the lowest shell that it can occupy. Electrons move between shells depending on how much potential energy they have at a given time, but they don't stop halfway between shells. So it's either in the first shell or the second shell or the third shell, but it's not at shell like 1.5. This just says what I just said. Okay, and why do we care? So the chemical behavior of any atom, just the things that a certain element, the way that it reacts, the things that it does, are determined by its electrons and where those electrons are in the different electron shells. We talked a little bit about the organization of the periodic table last time. We talked about how it was organized by protons. Each time you add a proton, you go up 1 number in terms of the atomic number of the elements. But the periodic table is also organized by where the electrons are located in the electron shells. So the innermost shell, kind of the ground floor, can only hold 2 electrons. Only 2 electrons can occupy that shell at a time. Hydrogen, which has 1 proton, has 1 electron, because remember, if we have 1 positive charge, we want 1 negative charge. So hydrogen has 1 electron in that outermost shell. Helium has 2 electrons in that outermost shell. And so that outermost shell, we say that it's full. That's as many electrons as it will hold. It's like if you had a hotel that was 3 stories, the bottom floor has 2 rooms. You can only rent it out to 2 guests, and then it's full. Then the next row of the periodic table, you add on the second electron shell, and you start to fill it with electrons. So lithium has 3 protons, so it has 3 electrons, and the first 2 electrons get put in that innermost shell, and then the third electron gets added to the second shell. So again, like if this was a hotel, your second floor has 8 rooms, you need to rent a room to the third person who comes in to rent a room, so you put them on the second floor. And then so on across that middle row. Beryllium has 4 protons and 4 electrons, so 2 of those electrons are in the inner shell, 2 of those electrons are in the outer shell. Boron has 5 protons and 5 electrons, so 2 again in the inner shell, 3 in the outer shell. Then carbon has 4 in the outer shell. Nitrogen has 5 in that second shell, that's the outer shell right now. Oxygen has 6, fluorine has 7, neon has 8, and with 8 electrons in that second outermost shell, that shell is totally full, right? Then we go down to the third shell. So now it's like our hotel, the bottom floor is booked, the second floor is booked. So now we have a third floor that has 8 rooms. We're going to start putting guests on the third floor. So sodium has 1 electron in the third shell. Magnesium adds a second electron in the third shell. Aluminum has 3, silicon has 4, phosphorus has 5, sulfur has 6, chlorine has 7, and argon has 8. So that entire outer shell is filled with electrons. So if you look at, if you look at the rows from left to right, on that first row, we're filling the first shell. From left to right on that second row, we're filling the second shell with electrons. From left to right on the third shell, we're filling the third shell with electrons. And then if you look at the columns, all of the elements in that first column here have 1 electron in the outermost shell. And we call that outermost shell the valence shell. And we call any electrons that live in the outermost shell valence electrons. And those are the electrons that are involved in chemical bonds. So those are really important electrons. So we'll keep talking about those. But so notice in the first column, they all have 1 valence electron, 1 electron in their outermost shell. In the second column, they have 2 valence electrons. In the third column, they have 3, so on all the way, 4, 5, 6, 7. And then that right-hand column, the 8th column, notice that helium has 2 in its valence shell, but that shell is still full. And then neon has 8 and its shell is full, and argon has 8 and its shell is full. So helium and neon and argon are all not very chemically reactive because their outermost electron shell is full and it doesn't want any more electrons and it doesn't want to give away any more electrons. It's just kind of happy to be full. So that is how the periodic table is organized. It gets more complicated because above this third shell, things just get a little messy, but this is the level we're going to go to for this class. So there you go.